Hey there, welcome to NASA Launchpad. I'm your host, Justin Tully. You ever wonder how astronauts train for working in reduced gravity? Well, there's actually a whole bunch of different training techniques and facilities for them. You've got stuff like virtual reality trainers, mock-ups, simulators. But what about the physical aspect of being in space? The reduced gravity, the floating around and all that. You've probably heard about the Vomit Comet. Officially, the KC-135, a plane that flies in parabolas, causing the feeling of weightlessness during the free-fall segments of the parabolas. I mean, they actually used that plane to film some of the scenes in Ron Howard's movie Apollo 13. And this kind of training is so important for our real astronauts that a newer version of the weightless wonder, the C-9B, is used by NASA today. But what about something a little closer to the ground? Do you know anything about the Neutral Buoyancy Laboratory in Houston, Texas? What is it? What does it look like? Well, it's basically a really big pool. It's about 61 meters long, 31 meters wide, and roughly 12 meters deep. That's even bigger than an Olympic-sized pool, and much deeper. I said it was really big. It holds about 23.5 million liters of water. That's almost 6.2 million gallons. It's so big, it also holds full-size mock-ups of space station modules. So astronauts can actually suit up, dive in, and train for their spacewalks. But it's not quite that simple. If you were to dive into a pool with a heavy spacesuit on, you'd probably sink, right? Not so weightless. That's where the neutral buoyancy comes into play. Neutral buoyancy is a condition in which an object's mass is equal to the mass it displaces in a surrounding medium. In simple words, a neutrally buoyant object neither floats nor sinks. To make an object neutrally buoyant, the object's mass needs to be equal to the mass of the water. The astronauts accomplish this with a combination of weights and flotation devices. Once neutral buoyancy is achieved, the astronaut essentially hovers in the water. But here's the thing. In the neutral buoyancy lab, the astronauts still feel their own weight as gravity tugs on them. So it's not exactly the same as being weightless in space, but it does allow the astronauts to practice moving heavy objects or performing fine motor tasks with those bulky suits on. Neutral buoyancy may not be perfect, but it is the closest thing to weightlessness you can get here on Earth. Of course, the astronauts in that big pool have to deal with another problem. Water drag. Even in neutral buoyancy, the drag of moving water slows down the astronaut's movements. Drag is a force that opposes the motion of a solid object through either liquid or gas. So an astronaut moving his arm through the water encounters resistance of the water drag. Or an airplane flying through the air has to deal with the drag force of the air. Or even when you're walking around, there's drag resisting your motion. Now granted, you're not going to be moving very fast, and neither is the astronaut. But in special situations, when you're moving at higher velocities, like an airplane or a rocket, it's important to understand the effects of drag forces. How do you do that? Well, NASA's got the answer. They're called wind tunnels, and they're used to check the fluid dynamics of objects. Some are large enough to test full-size planes or rockets, but most deal with smaller models. All kinds of things get tested in NASA wind tunnels, from airplanes to rockets to even NASCAR race cars. But what about a swimsuit? Yeah, a swimsuit. Like you use in a pool? A pool like we were talking about earlier with the astronaut testing? Yeah, see, it might seem like we ramble, but we bring it back. It all makes sense in the end. Anyway, yeah, a swimsuit. Because let's be honest, for competitive swimmers, drag is a huge deal. It's why a lot of swimmers wear swim caps, shave their heads, even shave their bodies. Hair, even a little bit, increases drag. Studies indicate that viscous drag, or skin friction, is roughly 1/3 of the total restraining force on a swimmer. And for these competitive swimmers who are working hard to perfect their form and improve their hydrodynamics, that's like aerodynamics but in water, every little bit helps. A few hundredths of a second can mean the difference between a gold medal and not placing at all. And that's why the Speedo company did testing on their Laser Racer swimsuit in NASA's wind tunnels. The result? Well, the numbers kind of speak for themselves. In the 2008 Olympics, 94% of the races were won by competitors wearing the Laser Racer swimsuit. And in those same 2008 games, over 60 world records were broken by swimmers in Laser Racer suits. That seems pretty effective, right? So how did the suit come about? Well, the first step was finding the right material. NASA researchers, working in collaboration with Speedo, tested over 100 different potential materials for swimsuits in wind tunnels. The materials were stretched over a smooth, flat aluminum plate and the edges were taped down. This was all done so that nothing would interfere with the airflow over the fabric. Each material was tested at a number of different wind speeds, which, with the help of sensors, allowed researchers to measure drag across the surface of the plate. In the end, after years of study, one material emerged. It was called laser pulse. This material was ideal because, for one thing, it is very efficient at reducing drag. It also repels water and is extremely lightweight. But the material is not the only consideration. You also have to worry about seams, which cause drag as well. But it turns out that the same technology that can be used to make perfect seams on NASA's new Orion spacecraft can do the same thing for swimsuits. Speedo ultrasonically welded the seams on the laser racer, rather than using traditionally sewn areas. Never heard of ultrasonic welding before? I hadn't either. Basically, high-frequency ultrasonic acoustic vibrations, sound waves with a frequency above the capabilities of humans to hear them, are applied to pieces of material that are being held together under pressure. This creates a solid-state weld. That is, the connection is made just by the material. There are no soldering materials, adhesives, nails, stitches, nothing like that. So the laser racer was the first fully bonded, full-body swimsuit with ultrasonically welded seams. And that alone reduced drag by 6%. Also, the zipper for the suit was ultrasonically bonded, but hidden inside the suit. That generated 8% less drag in wind tunnel tests than a standard zipper. So all in all, the laser racer suit reduced the passive drag of the fabric over the previous Speedo FS Pro suit by about 24%. When you're talking hundredths of a second between first and last, it's a huge deal. That's NASA for you. Learning from its research.